If you wanted to cross the vastness of the universe as quickly as possible, what route would you take? To answer that, physicists often look away from the stars and down at a simple piece of fruit, an apple. Imagine an ant trying to get from one side of this apple to the opposite side. Normally, it trudges around the curved outside skin, but if a worm chews a hole straight through the core, the ant skips the surface entirely, taking the direct shortcut. In the 1960s, the Princeton physicist Joan Wheeler used this exact idea to coin a famous term, the wormhole. Our universe behaves a lot like the skin of that apple. If the space we live in is curved, a wormhole would be a bridge that tunnels through the gap to connect two distant points. The formal scientific term for this tunnel is an Einstein-Rosen bridge, named after Albert Einstein and Nathan Rosen, who found it hiding in the math of general relativity. To visualize how their math works, picture our universe flattened out like a two-dimensional grid of paper. Let's mark Earth as point A and a distant galaxy as point B. Conventional space travel is like drawing a line across the page from one dot to the other. Even at top speed, this journey would take millions of years. But remember, space-time is flexible. We can fold the paper in half, bringing point A and point B right on top of each other. By punching a hole through both layers, we create an instant bridge between those two distant locations. By bending the geometry of the universe itself, distances that would normally take light millennia to cross could be traveled in mere moments. There is a catch to this math. General relativity definitely allows these bridges to form, but they are incredibly unstable. Gravity constantly pulls inward, exerting a crushing weight that snaps the tunnel shut violently before anything or anyone could ever cross through. To actually use a wormhole, you would need to build a structural scaffolding to hold the throat open against the intense crush of space. This slide shows the specific equations physicists use to calculate how to stabilize the tunnel. It reveals that the throat of the wormhole must be forced to stay open using a massive amount of outward pressure. To create that pressure, the math requires a substance with a negative mass. Instead of pulling things in like normal gravity, this material creates a repulsive outward force. Without this constant outward push, gravity is so relentless that a natural wormhole would instantly become a lethal, inescapable trap. Physicists called this required material exotic matter. It is a theoretical substance that disobeys the rules of normal physics by holding a negative energy density. While we can't mine this material yet, we've seen hints of it in the lab. Researchers found that if you place two metal plates incredibly close together, the vacuum between them has even less energy than the space outside, creating a tiny bit of negative pressure. If we lined the inside of our wormhole with this exotic matter, it would act like internal struts, constantly pushing outward and counteracting gravity's attempt to collapse the tunnel. Mastering this bizarre material would provide the anti-gravity scaffolding we need to turn a mathematical anomaly into a permanent cosmic subway. Because space and time are woven together, these shortcuts actually bridge two different moments in history. Let's try a thought experiment. Imagine we keep mouth A of our wormhole safely parked on Earth, and we load mouth B onto a spaceship capable of flying close to the speed of light. A core rule of special relativity tells us that time behaves differently depending on how fast you move. For the speeding spaceship, time moves much slower. The clock at mouth B is ticking far slower than the clock back on Earth at mouth A. When the spaceship returns home, mouth B will have aged less than mouth A. Their timelines are now permanently out of sync. Because the two ends are still connected, stepping into mouth A today means you would exit out of mouth B in the past. We have transformed a spatial shortcut into a functional time machine. Using a wormhole to travel backward in time introduces some massive, reality-breaking logic problems, most famously, the grandfather paradox. The paradox goes like this. If you use a wormhole to go back and prevent your grandparents from meeting, you would never be born to travel back in time in the first place. Modern physics attempts to resolve this headache using theories of parallel universes. Under these rules, traveling to the past and changing something simply splinters reality off into a new, alternate timeline, keeping the original intact. We haven't found a wormhole yet, and we haven't learned how to mine exotic matter, but the equations of general relativity allow for them perfectly. The math proves we live in a wild, complex universe, just waiting for us to find the right shortcut.
Do you have any ideas for my next video? Just write them down in the comments below, and I will explain it in the next one. Don't forget to like and subscribe. Thank you so much for watching.